Good morning, students. Okay, in the previous class you learnt about that basic operation on the integers. Let us recall once again the basic operation on the integers: addition, subtraction, multiplication and division. When you add the two integers, the result is also an integer. When you subtract the two integers, the difference of the two integers is also an integer. When you multiply the two integers, the result is also an integer. Then what about the division case? Let us see what about the division case. When you divide the two integers, means one integer with another integer, the result is always an integer or maybe other some other number. Let us see that. Divide 9 by 5. Now let us divide the 9 with 5. What is the result will be? 9 by 5. Where we know that 9 by 5 is a fraction, but it is not an integer, because the integer is the collection of positive numbers, negative numbers and the 0, but here we got the result is 9 by 5, where it is in the form of a fraction. So we call 9 by 5 is a fraction, but it is not an integer. Now what you can decide that when one integer is given, it may be or may not be divide the given integer with another integer to get the result is an integer. Let me take one more example. Divide 25 by 5. Now what is the result? Let us check it. That is 25 by 5. 5 ones, 5 5. So what is the result you got? That is 5. When you divide one integer with another integer, the quotient we got is 5, where 5 is also an integer. Now from these both examples, what we can conclude that it may be or may not be possible to divide the given integer with another integer to get the result as an integer. Sometimes maybe we will get in the form of fraction or when some form of fractions, or we get an integer. But we can't say that exactly we will get only a fraction, or we can't say exactly we will get a integer. So further the system of integers should be extended to the rational numbers. Now what is a rational number? Let us discuss the introduction of the rational numbers. Rational numbers. Now how we define the rational numbers? Why the rational numbers has introduced? Because whenever we divide the two integers, we are not getting the result always as an integer, no. Sometimes we are getting in the form of fraction. So further the rational numbers has arisen. Now what is the definition of rational numbers or the statement of a rational number? The numbers which are expressed in the form of p by q, where p comma q are integers and q is not equal to 0. So this is the statement of a rational number. The numbers which are expressed in the form of p by q, where p and q are integers and q is not equal to 0. And we call these rational numbers are also called as quotient numbers. What we call? And what we call these rational numbers are also quotient numbers. And we denote the rational numbers with the capital Q. And let me take some examples to explain about the rational numbers. Examples, let me take that. Minus 5 by 7, 9 by 2, 5. 5 by 3, minus 7 by 5, 4, 0, minus 7. Now here I have written some examples. From these examples, so let us see that which are the rational numbers and which are the integers and which are the fractions. Now minus 5 by 7, is it a rational number or a fraction or an integer or any other else? Let us see. Minus 5 by 7, it is in the form of p by q. What is p is here? Minus 5 and q is 7. They were the both are integers, so we call it is a rational number. So now minus 5 by 7 is the rational number. And what about 9 by 2? What is 9? It's an integer. 2 is also an integer, so we call it is also a rational number, because it is in the form of p by q and the denominator is not equal to 0. What about 5 by 3? 5 by 3 is a rational number or not? Let us see. What is 5 is an integer. What about 3? 3 is also an integer. 5 by 3 is in the form of p by q and these both are integers, so it is also a rational number. What about minus 7 by 5? It is also a rational number. Am I right? Yes, because minus 7 is an integer, 5 is an integer and it is in the form of p by q, so it is also an integer. What about 4 now? Now what is 4? You know that 4 is a natural number as well as whole number as well as integer. Now can I say it is a rational number? If it is a rational number, that should be the form of p by q, no? but it is not in the form of p by q. Then how we can say where 4 is a rational number? We can write that 4 as 4 by 1. What is the value of 4 by 1 is 4 only. Now what you can say about the 4 is 4 is also a rational number, because we can write that 4 as 4 by 1 where it is in the form of p by q. Then what about 0? You know very well. What is the 0? 0 is an integer as well as whole number. Can I say 0 is a rational number? If it is a rational number or if it is not a rational number, how you can say that? I will say that 0 is also a rational number. Why? Because we can write as 0 by 1. Not only 0 we can write as 0 by 1, we can write as 0 by 2 or 0 by 3 or 0 by 100. Whatever you want, you can write in the denominator with number, but not 0, because the condition is given not equal to 0. Now what you can say? 0 is also a rational number, because we can write in the form of p by q. What about minus 7? We know that very well, minus 7 is a negative integer, but I will say that it is also a rational number. Why? Because we can write as minus 7 by 1 where it is in the form of p by q. Now it is also a rational number. From these examples, what we can conclude? That all natural numbers, all whole numbers, all integers are also rational numbers. Why? Because every natural number can be expressed in the form of p by q. By this example we can say, and every whole number also we can write in the form of p by q, because we can write as 0 by any number other than 0. And what about the integers? Integers also we can write in the form of p by q by writing with the denominator 1. So from these examples we can conclude that all natural numbers, all whole numbers, all integers are also rational numbers. Pass. Okay, till now I explained the examples of rational numbers. Now I want to give one more example. Now let us discuss whether it is a fraction or a rational number. Example, that is 7 by 20. Last example, to say whether it is a rational number or not, or any other number else. Now 7 by 20. What do you say about this number? It is a rational number or a fraction? Now I will say it is a fraction as well as a rational number. How? Now look at here. What is 7 is a integer. What is 20 is a integer. So now these both are integers. No. How will you say it is a fraction? A fraction which is in the form of a by b, where a and b are whole numbers. But here both are integers. But we know that all whole numbers are part of integers. Now here it is in the form of a by b, where a comma b are whole numbers, and the denominator is not equal to 0. Now we can say it is a fraction, because it is in the form of a by b, where a and b are the whole numbers and the denominator is not equal to 0. So we can say it is a fraction. But I will say it is also a rational number. Why? Now look at here. 7. What is 7? It is a whole number as well as integer also, which is a positive integer, and 20 is also a positive integer. Now these both are positive integers and it is in the form of p by q also. 7 by 20 is equal to p by q. Here p is 7, q is 20. Now these both are integers, it is in the form of p by q, and this where denominator is not equal to 0. Now we can say 7 by 20 is a fraction as well as an rational number. Let me take one more example. Minus 9 by 10. Now is it a fraction or a rational number? Obviously it is a rational number but not a fraction. Why it is not a fraction? Let us see now. What is minus 9? Minus 9 is an integer. What is 10? 10 is also an integer. So we call it is a rational number. P by q form. It is in the form of p by q, where these both are integers. So it is a rational number but not a fraction. Why it is not a fraction? Because minus 9 is not present in the set of whole numbers, where it is a negative integer. So the condition of the fraction is not satisfying. What is the statement of fraction? A number which is in the form of a by b, where a and b are whole numbers, I said. But here minus 9 is an integer. It is not satisfying the statement of fraction. So it is not a fraction. It is only a rational number. So from the previous examples, what we can conclude? A fraction is a rational number, but a rational number is not a fraction. Okay. So this is about the introduction of the rational numbers. So let me revise once again what is a rational number. The rational numbers which are expressed in the form of p by q, where p and q are integers and q is not equal to 0. And these rational numbers are also called quotient numbers. Why these rational numbers are called the quotient numbers? Because now for example 5 by 2, now it is a rational number. Now if you divide 5 with 2, we are going to get the result. What is the result we call? Let us see now. What is 2? 2 is the divisor and 5 is the dividend. Let us divide that. 2 2's 4, 5 minus 4 is 1. Here it's not possible to divide with 2, 1. So for that I am keeping the point 0, 2, 5 is 10. What is the result? Is got 2.5. Now what we call the answer in the division of 5 and 2? That is called quotient. That's why these rational numbers are called quotient numbers also. Let us see one more example. Root 2. Now what is root 2? Square root 2. Is a square root 2 rational number? If you say yes, how? Let us see now. We can write root 2 as root 2 by 1 now. In the previous examples I said that every natural number, every whole number, every integer we can write in the form of p by q by writing with the denominator 1. But root 2 we can write as root 2 by 1. It is in the form of p by q, no. We can say directly it is a rational number, no. But no, it is not a rational number. Why? Because the p by q I said, okay, form is okay, but the numerator is not a integer. It is an irrational. That you will learn in the upper classes, higher classes. So here root 2 is not an integer. That's why it is not a rational number, because the condition of the statement is not satisfying. Root 2 is not an integer. That's why it's not a rational number. To say that given any number is a rational number, compulsory that should be in the form of p by q, and p and q should be integers and the denominator should not be equal to 0. I said the condition that is q not equal to 0. So why the q should not be equal to 0? Maybe you will get the doubt. Okay, now look at here. For example 5 by 0. 5 by 0. Can you divide 5 with 0? If you are able to divide 5 with 0, then what is the result is? Can you say the result? We can't say the result. That is quotient. For example 0, 5. 0 is the divisor, 5 is the dividend. Now I can write here 0, 5 is a 0 into 5, 0. Again 5. Not only 0 into 5, 0. If you multiply any number with 0, the result you are getting the 0 only, no? Means we can't say the quotient exactly. That's why the division of any number with 0 is undefined. Because you are going to get the quotient different numbers and the division is not ending at all. Or simply we can say that whenever you multiply any number with 0, the result is 0. So that's why the division process is not applicable here. So whenever you divide any number with 0, we can say the answer is undefined. That's why the denominator should not be equal to 0. Okay, now till now you have seen the introduction about the rational numbers. So in this chapter you are going to learn about the introduction. Already you have learned about the introduction of the rational numbers. Next, representation of the rational numbers on the number line, properties of rational numbers. Let me write introduction. Introduction has completed about the rational numbers. Second, properties of rational numbers. Properties of rational numbers. Third topic is representation of rational numbers on number line. And third and fourth is rational numbers between two given rational numbers. Next, fifth is decimal representation of rational numbers. So these are the topics you are going to learn in the first chapter. Already I gave the introduction about the rational numbers. Next you have the properties of rational numbers. Next, representation of rational numbers on the number line, rational numbers between the given two rational numbers, and decimal representation of rational numbers. So these are the topics you are going to learn. Now let us see about the properties of rational numbers. In the earlier classes, you have learned the basic operation on the rational numbers, means how to add, how to subtract, how to multiply, and how to divide the rational numbers you have learned in the earlier classes. And now let us see the properties of operations on the rational numbers. Let us see the properties of operations on the rational numbers. Properties of whole numbers, properties of integers you have learned. In the same way, we are going to apply the same properties on the rational numbers. So what are the properties are? First one is closure property. First one is closure property. Second one is commutative property. And third one is associative property. So these are the three main properties. And you have other cases, that is roll of 0. Fifth one is roll of 1, and sixth is additive inverse, and seventh one is multiplicative inverse, So these are the properties which you are going to learn now, but not this all the properties. In the next class we will learn about the associative property, roll of 0, roll of 1, additive inverse, and multiplicative inverse. Now let us see about only the closure property and commutative property. First one, closure property. Let us discuss the properties of rational numbers, closure property under addition. First one is addition. So we are going to apply that all the operations on the properties of rational numbers in closure property. Now what is the closure property says about? The sum of the two rational numbers is also a rational number. We can say that the rational number satisfies the closure property under addition. Further, let us consider the two rational numbers. Consider two rational numbers. That is 7 by 5, other one is 2 by 3, let us say. Now let us add these both rational numbers. What is the result you are going to get? Let us see. 7 by 5 plus 2 by 3. Now how to add the two rational numbers? Now if you observe clearly, the denominators are different. For that you need to do the LCM. 5 comma 3. The LCM of 5 comma 3 is 15. Now what about here? 3 7s 21 plus 5 2s 10. So what is the result is 31 by 15. Now the sum of the two rational numbers, we got a rational number. Now what you can say that from this? The rational number satisfies the closure property under addition. How we can say that? Because when I add the two rational numbers, the result is also a rational number. And let us take one more example. Let us take again two more rational numbers. Minus 5 by 2, other one is 3. Now let us add these both numbers and we will check the result whether you are going to get again the rational number or not. Minus 5 by 2 plus 3. But here 3 is also a rational number, we know that, because every integer we can write in the form of p by q as by writing the denominator with 1. Now what is the LCM? 2 comma 1, the LCM is 2. 1 into minus 5 plus 2 into 3, 6. Now what is the result you got is 1 by 2. What is 1 by 2? Is a rational number. So from this we can conclude that the rational number satisfies the closure property under addition for any two rational numbers. Why? Because the sum of the two rational numbers is always a rational number. Okay students, and now whatever I explained, just revise that. The topic what I explained about the introduction of the rational numbers and the statement of the rational numbers and examples, and what I said just closure property, and you take 2 or 3 examples for the closure property and find the addition. Are you going to get the same result or not? Once check it. Take the two numbers and you find the addition. are you going to get again the rational number or not, whether it is satisfying the closure property under addition or not. And let us continue the remaining properties in the next class. Thank you, students.